Alright, so welcome back to your favorite inorganic tutor YouTube channel. Today is another episode. We want to look at how we can find the derivative of the Euler's number, right? What we already know as Euler's number, which is E, right? So first of all, when we have a function like this, right, the Euler's number with a function, when we want to find the derivative of that particular function, first we have to multiply the function, right, the exponent by the function, right, then times the natural log of the base itself, right. So this is what I mean. So the derivative of this particular function, right, we are going to have, we multiply the function itself. So we have this x squared minus x times the derivative of the exponent, right? So we have the derivative of the exponent, right? So this is how we differentiate the Euler's number, right? So here, and we know that this has a base of 10, right? Um, the natural log base, right, which is times the differential of the ln, right? And we know that this will automatically give us 1, right? So we have here e power x squared minus x times the differential of x squared minus x, and that gives 2x minus 1, right? Times this is automatically 1, right? So we have dy dx equals 2x minus 1, then e power x squared minus x, right? So this becomes the differential of this particular function. Now let's try another example and see. So the key aspect is that we have to recognize when we have to use the chain rule, right? And this here we have an exponential function, and the function on the exponential function is cube, right? So we have to use what we call the chain rule, right? So here we maintaining the function, we have e power x squared plus 1 all cube times, when you differentiate this, right, you have bring the 3 down, then you take 1 from the exponent, so we have x squared plus 1 all squared, right? Then we differentiate the inside, right? So we have 2x. Of course, this will be 0, so we have 2x here. So we have dy dx is equal to e power x squared plus 1 cube. Then this, of course, is going to be 6x into x squared plus 1 squared, right? So this, we can bring the 6x here and then bring, so that we send the exponent back there. So we have here dy dx equals 6x into x squared plus 1 all squared. Then we have our function e power x squared plus 1 all cube. And that becomes our final answer to this particular problem, right? So the key idea is that you have to know when to use the chain rule, right? This is, we have to apply the chain rule over here and we'll get there. So let's look at the third problem and look, we'll get to know different types of questions on this particular topic, right? So the next problem is 3, y equals e power x, right? So this here, we want to differentiate this particular function, right? So we have dy dx equals, we differentiate, no, of course we have to maintain the function itself. So we have e power x, then we differentiate the function on top, right, which is x, and that becomes 1, right? So the reason why whenever you have e power x, you differentiate and you get the same result is because of the exponent here. It's just an x, and you know that when you differentiate x, you're going to have 1, and the result remains the same. So right, we have e power x as our final answer again. Right, so let's look at the fourth example, which is y equals e power minus s squared. Right, so this same idea we are going to apply here, right? So we have dy dx equals maintain the function and then differentiate the exponent, right? So we have differential of x squared, of course it's negative, so we have minus 2x here, right? So we are going to have minus dy dx is equal to minus 2x e power minus s squared. And this becomes our final answer to this particular question. Right. Let's look at the final example on this particular topic. Right. So the final example, which is problem 5, will be equal to, that is equal to e power 2x. Right. So the same idea as we used over here, the same thing we are going to apply over here. So we have dy dx will be equal to maintain the function, which is e power 2x, right? Then differentiate the exponents here, then we have 2, right? So we have dy dx equals 2 e power 2x. And that becomes the final answer to the problem. Thank you very much for watching. Keep on watching. I'll give you more content as well. Bye.